Landsat team data.
Good afternoon, Cheers and everyone. My name is Chen. So today we are going to give a presentation titled with extraction of bone forest area in the Great Highland Mountain of China, based on Landsat TM data. I will outline the presentation following the four aspects. First, background, then second, give an introduction about the method. The third part is to show the result and to make some discussion. The final one is some conclusions. Okay, now start from the first part, background. We know that the Great Highland Mountain, also named as Daxing'an in Chinese. So it is located in the northern part of Heilongjiang province and in the Mongolia autonomous region is latitude and longitude. It is an important climate zonation with typical cold, temperate continental monsoon climate. Its annual average temperature and annual precipitation. It is China's largest forest area with a total ground area and a forest area. So it is also a mixed forest area with coniferous and broadleaf species. We know that the forest disturbance and recovery has been proposed as a primary mechanism for the carbon transferring between the atmosphere and the land. So it is not only crucial for the carbon budget related research, but also important for the forest monitoring and management. So we know that the forest fire is very important for disturbance factor. It may be a dominant one in boreal forest. So for our study area, the Great Highland Mountain, it is rich in forest resources, but also in a high incidence of forest fires. Its annual bone forest area ranks first in China, which makes it to be the most serious forest fire hazard areas. Taking the 20 years from 1987 to 2006 as an example, during this period, there are totally 1,059 fires happened, which results in a large coverage of such burned area and burned forest area. When averaged to each fire and each year, there were also very serious figures, I think. Among all the fires happened in this area, the one happened on the day of May 6, 1987, was one of the most noteworthy ones. It is the most serious forest fire since the founding of China. Here the China refers to the People's Republic of China, so it's just from the year of 1949. And during that day, there are 4 forest bureaus of Xinlingji, Tuxiangma, and Tahe on fire almost at the same time. The fire continued to burn as long as nearly 1 month and caused great loss of both life and property. So this figure shows the loss resulted from this fire. So here we will focus on the 2 indicators of burnt area and burnt forest area. We know that among all the consequences of this serious fire, the 2 crucial indicators of burnt area and burnt forest area are 2 very basic and direct indicators to indicate the loss of this fire. And the figures are acquired by field survey and official statistics at about 25 years ago. So the accuracy needs to be validated using some modern techniques such as remote sensing technologies. When using the remote sensing images, generally the method of classification, including supervised and unsupervised classification, are used to detect the forest disturbance resulting from various factors. So as we know that it is a very serious fire, stand replacing fire, so a much easier method of threshold segmentation also performed well. Now the second part, methods. It is our study area. The polygon in green indicates the area of the Great Himalaya Mountain, and from the color composite of the Landsat TM images, we can know that here is the result of the forest fire. You can see it very obviously. And here, the images used for the color composite and extraction was two things. One is acquired on June 15th in 1987 for this thing, and another is acquired on June 24th for this thing. And for the pre-processing of the images, the dim images were converted to the surface reflectance. As the boundary of the burnt area is very, just by the visual interpretation is very obvious. So here we extract the fire parameter using the visual interpretation. Then the burnt area, it is a burnt land area was calculated. And we know that some rivers, roads, and building area was also within the burnt area. So some was within the burnt area, but some was not. So here we also extract the rivers, roads, and buildings by visual interpretation to minimize the impact on the forest area extraction. So now only the forest area remains. It will be very benefit our extraction of the burnt forest area. Okay, this is the pre-processing result of our Landsat TM images. In this figure, we can find the roads in green lines and the rivers in the blue lines, as well as some building areas. So the yellow polygons indicate the parameter of the series for fire. Here the indices we selected for our extraction of 4 indexes. They are all very famous and frequently used in the many applications. The NVI, EVI, VFC, and DI. For the former two, NVI and EVI, we don't need to introduce more. And for the VFC, it is a vegetation fractional cover. It was acquired based from the NDVI using the SMA methods. So for the DI, it is an abbreviation of disturbance index. It acquires from the Tesla transformation. After this transformation, we can get 3 indices of brightness, greenness, and wetness. Then after the spectral normalization and the simple calculation, we can finally get the disturbance index. So we know, okay, it is the result of the 4 indexes we calculated from the images of surface reflectance, the NDVI, EVI, VFC, and the DI. From the 4 figures, you can very obviously find the burnt area which are very different from the surrounding areas. Here we also select a sample by the stratified sampling method and to illustrate the histograms of the forest zones, including the burnt and unburnt forest areas. These are the histograms using the 4 indexes. Just using the histograms, we determine the optimal threshold for the segmentation using the 4 indexes. Now we come to the third part of results and discussion. We know that the threshold for separation of the burnt and unburnt forest area using the 4 indexes was determined by their histograms. The burnt forest area was extracted based on the acquired threshold, and another group of text samples was used for the accuracy evaluation. So here, this figure shows the accuracies achieved using the 4 indexes. So from this figure, we know that the extraction using EVI can achieve the highest accuracy with this overall accuracy and kappa coefficient, and then followed by the indices of DI in the purple bar, and then the extraction using NDVI and the VFC are the lowest, but also very high in these cases. Why is such a difference in the extraction using different indices? So here we would like to make some exploration about the reason of the differences. So here we can see from this figure of the spectral signatures of forest zones, including the burnt and unburned forest area. The x-axis is the 6 multispectral bands of the TM sensors, and the y-axis is the surface reflectance. We can find that in the band 4, in the near-infrared band, there are the largest difference between the burnt and unburned forest area. Then is the band 7. Then for the band 1 and the band 3, there are little differences. Seems not so significant. But for band 2 and 5, there are almost no difference between the burnt and unburned forest area. So we know that the EVI uses the information of 3 bands of band 1, 3, and 4. But for NDVI, we use only 2 bands of 3 and 4. So here, the EVI use 1 more band compared with NDVI, so it achieves higher accuracies than NDVI. But for the VFC, we know that it is calculated from the NDVI, so it also uses the same bands of 3 and 4, so it achieves maybe similar accuracies. It approximately equal to the accuracies when using NDVI. For the DI, we know that it takes use of all the bands of the TM images, so including the 1 to 5 and 6 and 7. So we know that although it incorporates all the significant bands of such as 4, 7, 1, and 3, but it also includes the 2 insignificant bands of band 2 and 5. So it can achieve a higher accuracy than NDVI and VFC, but lower than that of EVI. So now we will think that if you only use the 6 single band reflectance for the extraction, what will be the result? So okay, now it is a result. The same samples and methods was used for the extraction using the single band reflectance, and this figure shows the result of the six bands. First, focus on the purple bar. It is the result of band 4. Also, it is the highest accuracy, and then also the band 7, then followed by band 1 and 3. The result of band 2 and 5 are the lowest. So it is consistent with the result of the spectral signatures of the forest zones. And when compared with the results using the 4 indexes, we know that the EVI also achieves the highest accuracy. Then is the band 4, DI, band 7, and then the NDVI and VFC. So we know that by the comparison among all these indices of the single band reflectance, we know that the EVI threshold can achieve the highest accuracy. So it was used for our final extraction, and the result was considered to be the optimal and our final output. So we calculate the burn area from 5 per meter and burn forest area, and then compare them with values from our official statistics. This is the comparison between the remote sensing-based result and the official statistic values, and you can find the difference among the two groups of values. Maybe we think that normally we will think that the field survey result to be more accurate than result from the remote sensing data. But you know that this statistical values was acquired at about 25 years ago, and that was a special period in China, and you know we have also communicated with the local forest bureaus in the field survey in last year, and we know that the statistical process seems a little clever, and it must be very subjective. So for the remote sensing, we know that this extraction should be more objective and efficient, and it's less labor and time consuming, and it's at least repeatable. So now the conclusion is just several tips. And all the above indicates that the extraction accuracy depended on not the number of the bands we used, but the amount of significant information contained. So in some cases, simplest is the best. And during our actual applications, we should not blindly pursue the complex models, but select the most appropriate methods according to our specific needs. So it's not suggestion that the more complex, the high accuracy achieved. So it is our reminder. That's all. Thank you very much.
Okay. Any question and comment?
Yeah. And hi, thank you, good presentation. I have a brief two questions I want to ask. The first one, according to your page 15, you have to do the model accuracy. You have to do the aerometric. I mean, you get the overall accuracy and the Kappa coefficient, right?
Yeah, yes.
And it's do the classification, the prediction map, or I'm not sure. I'm not clear sure the results because I further want to ask, do you have the split the data for one part for the training data, the other part for the test data?
Yes, we have stated that another group of the test samples, just by our visual interpretation to select two groups of the samples and
randomly choose the training sample.
Yes, of course, randomly stratified sampling. It's randomly, so it's two different groups of data for the training and the testing.
Okay, so your conclusion is show very high accuracy. So I'm not sure why so very high performance. Maybe it's just a case for case. But in my opinion, when you use the test data, I don't think we're very high approaching 100% so perfect accuracy. So I just, in my opinion, want to ask that's a problem. And the second, according to use the Lancet T and the 7 band, and why
Yes.
do you have considered the 6 band? Because your study case is try to focus on the forest fire, right?
Yes.
Why don't you consider the band 6? It's a thermal band. So why don't you consider that?
Yes, we have. In fact, it's very good. We have considered the 6 bands, but it's the thermal bands. It's about the temperature. So, as the two images are in different time, but the time is not so apart from each other. And the temperature is also effective. We have also considered, but in this case, that it is different from the multi-spectral bands. So we didn't this result here I think it's not so consistent with our topic here. So it is a very good question. We have also considered the thermal bands of 6 bands. For the first question you have stated about the high accuracy in this case, I think it's just the case in case, it's just in this situation. In fact, I also conducted the classification, the supervised classification, and using the maximum likelihood classifier, and also it can also achieve higher accuracy. So maybe I think it is a very serious fire. Maybe you have heard of this fire as a Chinese, I think. And yes, so I think it is just the situation of this case.
Okay, thank you. Right.
just to introduce the next speaker,